Hello everyone. Today we're going to be talking about Leetcode problem 1493, longest subarray of ones after deleting one element. So this problem, conceptually is, I think, pretty straightforward. We have an array of ones and maybe other numbers, and we need to find a position to delete such that we end up with the longest string of ones possible. So for example, in this array, if we delete this 0, we end up with this array, which has, a subarray of 5 ones, and that's the best we can do. So let's go right into the sort of problem. So the main idea that we're going to work off of is processing the array in one pass and remembering two things. One, the number of ones in our current subarray, and two, whether or not the previous subarray is a valid subarray to combine. So let's try this. We'll start here and we'll record our current solution is 1. And let's also sort of say our previous subarray is not valid, right? Because there's nothing over here. We go here and we still carry this and we move on down the array in linear time, and then we get here and we say, well, it's a 0, so this right now our best answer is 3, so maybe we store this somewhere up here. And we get here and we say, and actually we can maybe do a little bit better as long as we're not at the end of the array. We can look ahead and say, is that a 1? And if it is, then this sort of 3 we discovered, maybe we put it here or wherever. The current sort of 3, the previous segment, maybe we put it here instead. The previous segment's size is actually a valid thing to combine, right? So we can maybe not even fill that in, and this would be 1, and the previous segment is valid to combine, true, or we don't even really need to record the true or the falses. We can just sort of store that in a single variable, and we can realize that, oh, the best we could do is actually the sort of index here all the way up to the index here, and that would sort of be an array of size 4. Right, so the best we can do here is 4, and that would be our answer. We don't want to write 4 here really though, because if there's a 1 here, or if we write a 4 there, right, when we get here and we realize there's an array here, we actually need to remember what this specific subarray was, because when we get up to here and we start sort of counting this subarray and we realize, oh, there's 5. Right, this is of length 5. We would store on our Boolean variable, when we look at this subarray, the previous subarray is valid. So our best answer, instead of sort of 4, would go to 6. So 4 would come from sort of these two numbers, and 6 would come from these two numbers. Okay, and that's I think sort of pretty straightforward algorithm. Keep moving forward. Once you get to this index, you would look at this 0, look ahead, and say, oh, this subarray at 5 of 5 is not a valid subarray to combine with the next subarray. I don't know when it is, but whenever it is, we can't combine it. So we get to this 0. And then we get here and we process this as a 2, and we could imagine that there's tons of stuff after this, etc., etc. But for all intents and purposes, in this example, the best solution is going to be 6. We delete this element and we combine sort of this single one with this group of 5. So that's the algorithm. I think it was pretty straightforward. This clearly runs in O of n time, linear time. So if you have any questions, comments, leave them below. And as always, the code will be on GitHub, and the link will also be below in the description. Thank you.